So I've done a cutaway drawing, a 3D drawing of what the rudder stock looks like with the quadrant and the quadrant arm or tiller arm on. And you see the lines there that have to line up, they have to be parallel. The hole, the sensor's second hole, and the central axis of the rudder stock and the sensor arm. So last night we gave the timber a coat of epoxy and painted it this morning with some white acrylic just to protect it in there. It doesn't really need protection, it's a dry area, but it should be okay. I've mounted the arm in the correct position, and those two little arrows line up when it's the ongoing issue with our autopilot has come to a head now. When we came across from Sicily, we lost the autopilot, and the sensor kept saying, the computer kept saying that the sensor wasn't working or it needed recalibrating. We checked the rudder bearings and everything when we were out in Tunisia, so we know that the rudder's okay, and we went through all the steering gear and the quadrant and everything as part of our normal maintenance, and we just thought, oh well, it needs recalibrating. So when we got to COS, I recalibrated all of the electronics side of the autopilot. It's a bit like swinging a compass. You have to do circles and steers, and everything seemed to be okay for a couple of days. I also took the autopilot RAM out. Now we've got Garmin electronics here, chart plotter, and it's a Garmin autopilot, but the actual RAM is by Jeffa. I took all that out, cleaned it, serviced it, couldn't find anything wrong with it, put it all back together again, and all seemed well for another week or two after we'd calibrated it. And then it started losing again, and the other day we came 15-20 miles from Gochek to Fethiye, where we are now, and the autopilot packed up again, and when it packs up, what it does is it either steers hard to port or hard to starboard, and you basically round up into the wind or you do a jibe. I did some bit of research, and to be honest, Jeffa have been quite helpful, but the most information I got was from the forums, particularly Bavaria owner forums. And what it is it appears that inside the Jeffa RAM there is a sensor, and this sensor is a rudder position sensor, so it tells you where the rudder is, but it tells the computer where the rudder is. And that sensor is what's called a 10-turn 10 kiloohm pot or potentiometer. Now, potentiometer, the best way to describe it, a potentiometer, it's a variable resistor, and as you turn it, the resistance goes up or down. In this case, 10 kiloohms, and it's like your volume control on your radio or your amplifier. After a few years of use, you'll get a little bit of crackling sometimes on the potentiometer, on the volume control as you turn it up and down, and that's what's happened with the sensor on our autopilot. It's got dirty, it's got dead spots because it's a physically touching mechanical joint that's got dirty. You can replace that, and Jeffa have offered to replace it for us. The problem is that we're in Turkey, we've got to get it here, we don't know how long it's going to take. Reading through the forums, and I can't remember who it was that suggested it, there's another way to do it. There's another way to sense where the rudder is and where the steering is. And that's why we've been out and bought this. It wasn't cheap, it was about a third more than I can get it for in the UK. And this is a Garmin rudder sensor. So there's bits and pieces in the kit, but basically this sensor mounts on a bulkhead. This threaded rod goes to the steering quadrant and it senses where the rudder is. You set it all up, calibrate it, and it does the same thing. Now, why have I gone for this? The reason I've gone for this is that this has no mechanical parts inside it. It works by magnetic proximity, from what I can work out. So as this moves and the sensor changes, rather than changing the resistance, it sends there's a magnet in there and a proximity meter, and what that does is it senses where this arm is rather than creating resistance. So there's no mechanical touching pieces in there. It's done by electromagnetism. Now we have to clear out our aft cabin again, commonly known on board Impavidus as the garage, and I have to set this up. It's virtually plug and play because it's got a Garmin standard 12-pin plug on it. That plugs into our course computer. We then recalibrate it. Bob's your uncle, Fanny's your aunt. Everything should be good again. And what we're going to do is leave the Jeffa sensor on there, on the RAM, but we're going to disconnect it, and obviously this goes in the same place. So the next thing to do, darling, is to clear out the garage.
Why are you looking at me?
There's actually some good instructions from Garmin in 7 different languages. Luckily, one of them is English, so it tells you all the parameters that you have to set up and how to do it. So it's pretty basic stuff. What we might have to do is this sensor works in that plane like that, and what we may have to do is make an angle bracket, either out of wood or out of a piece of aluminium, an angle bracket for it to sit on, and it sits like that, and then that rod goes across to the quadrant. So we'll get started on that and see how it goes. Well, I'm kind of squeezed in this little hole here. That's, if you can see it, this is our steering quadrant, and that is a Jeffa steering system, and we're going to have to fix that on there. Now, there are actually a couple of holes that show it under there for that to go on. I may have to drill through this. Let's get this in the right position. I may have to drill through this arm because that's where that steel rod goes to, and I don't think that there's room this side to put a bracket on. So we are going to have to look at where we kind of got to the bottom, had a look inside there. Now our quadrant actually faces the other way, so this is the bow of the boat and this is the stern, which means that this needs to be fitted on the same parallel axis, and the only way we can do that is to make a bracket 260mm long, something like this piece of timber that I've got here, and luckily we've got some offcuts of marine ply and teak there. What we're going to have to do is to make this bracket something like that, and mount it, and then this is going to have either an L-shaped bracket or a block of timber that's square put on the end in order to give us this, and then we can actually use a screw through here somewhere into our bulkhead. We've got a bulkhead that comes down here, and that will give us those dimensions, which is a bit of a pain in the backside, but it's the only way we can do it. Now our quadrant on the top, I'll see if I can do a freeze frame picture, but our rudder stock is like that. Our quadrant arm comes off of it like that, and our autopilot goes on there, and then just above that there's another quadrant with all the steering cables on and the springs and the adjusters. And the problem is that this is cast, and it's cast with a web in it, which is diagonal, sits at about 30 degrees off to that shaft, which means that I can't put this little mounting bracket on there because it has to be parallel to the rudder stock, and you can see it's about 30 degrees off. So it's got to go on here. There's already a hole in the right position, but that's an M6 thread and it's an M8 hole, so we'll cross that when we come to it, but I think I've got a solution. So first we've got to make this bracket. Let's see if we can find some timber the right size. So not ideal, but there's a little boatyard over the end of the harbour, and I just walked past one of their skips and skip ratted some bits of it looks like some kind of spruce. It's fairly dense grain. I've got some stainless steel screws. What I'm going to do is screw this down to this block here, which is about 1 3/4 square, and then I can screw through into that. It's not ideal, as I say. We can make a bracket up in the winter perhaps, but I can then cut this off flush, and that gives us the base of our bracket. There's no load on it other than the turning of that arm, so that'll be plenty strong enough. Alright, let's get these. So I'll put a couple of holes in here and here, maybe a little bit of epoxy on there. Yeah, I think I'll probably give this a coat of epoxy or something just to protect it a little bit. I mean, it's dry in there, but that will do. So I'm sure you've all seen a screw being put in before now. Just a pilot hole into the timber, and then this plywood, slightly bigger hole to take the shank of the screw. That's on there solid now, and I can cut that off square. Put 2 holes in the other way. Bob's your uncle. It's hot. It's mid-October and it's still hot. This isn't quite flush with that timber, and it's got to be exactly 90 degrees, so put a little chamfer on that. That's it. So that's me skip ratted piece of wood. Went up to the boatyard and I thought I was going to have to buy a piece of timber, but managed to skip rat it. So I am a skip rat and I'm proud of it. It didn't cost me nothing. And luckily we bought all our woodworking tools with us. It's a shame we can't do it on solid ground, but we're at anchor. Right, that's that bit done. Now I have to drill a couple of holes in there. Okay, so the bracket's made up. I've got it here, and this is the quadrant that we've got to fit our push arm to, push-pull arm. I've just taken a piece of this 45mm square, 1 3/4, whatever it is, and clamped it on that quadrant, because the instructions say that the quadrant arm and the bracket need to be at 90 degrees. So I thought I'd just check that the bulkhead is at 90 degrees. And when I line that up, if you can see behind this cable, when that is on there, there is actually a gap at the bottom. So the bracket is square to the quadrant, but at the bottom here, a bit hard to hold the camera and mark it all at the same time. So something is out of square. I suspect that the angle of the bulkhead and the angle of the rudder are not the same. There we go. If you look behind that black wire, this piece of timber is clamped to the quadrant, this top piece, and that's being held flat on there by my hand, and behind there there's a gap at the bottom and no gap at the top, which means that something's out of square. Now it's only 3-4 mil, just over 1/8 of an inch maybe, but we can't do that. It says that they must be parallel, so I've now got to make this, having just spent 5 minutes planing it square, I've now got to plane it out of square, which is a pain in the in a second I'm going to get you to swing the steering full port and full starboard, yeah? So I need to just check that the quadrant isn't going to interfere. If you go, cable's in the way. If you go fully, oh, hang on, my light's gone out now. Okay, come fully to starboard. Okay, and fully to port. Okay, so it doesn't come past, right, I'm just talking to myself, it doesn't come past there. So with the boat in a complete shambles, and almost every tool I've got out from under that bunk there, and under that bunk there, we have transferred that angle, the angle at which the bulkhead is out of line, which is that angle there. You can see, using a bevel gauge, and just flip the bevel gauge over where I measured it. So that was the other, that's the opposite angle, using a bevel gauge, flipped it over, planed it down. You can see the pencil marks where I marked the old one. So that is now tapered to the same angle that the bulkhead is out from the steering quadrant. Now the steering quadrant is vertical and the bulkhead that slopes slightly. Now the reason that we've done that way is because this is going to go up the other way. Hello, Oscar.
Roll on to me, you got me bed. Where's me bed?
Sorry, mate. So the next thing is that this sender sits up from, when it's mounted on this, sits up, and that goes in that second hole. So we needed to know the distance between the top of that arm and the bottom of this bracket, so that we could set this down the correct amount, if that makes sense. I'll do a diagram. So I've done a cutaway drawing, a 3D drawing of what the rudder stock looks like with the quadrant and the quadrant arm or tiller arm on. And you see the lines there that have to line up, they have to be parallel. The hole, the sensor's second hole, and the central axis of the rudder stock and the sensor arm. And the link rod has to be as near horizontal as possible, so the height of the bracket and the sensor is critical. And that's because the quadrant, obviously, if that was there, this is our quadrant here and we're mounting like that, let's say. The quadrant is up here and this bracket needs to be considerably lower. It's actually 42mm lower. So when I clamped that piece of wood to the quadrant to get this square and discovered the bulkhead wasn't square, I used a piece of 44mm, 45mm timber, and now I've got the same piece which I'll block off, measure down, and then I'll move it another 2mm down with a spacer. I've got some 2mm spacers aboard, and that will then be exactly at the right height for this to be mounted on it, like that. And then this arm in the second hole there will go across, and then that will go into there, and the height of that bar when it's in that hole is exactly 71mm to be parallel, which I've paralleled up. I used some spacers to measure it, used a engineer's rule to measure it all the way across, got it parallel, worked out how much the difference was. Right, so we've moved on a little bit. We've fitted this in place up the right way. It all fits. It's parallel with the quadrant arm. I then took a square, engineer's square, measured one side of the rudder arm at the top of the taper on the forward side, and then on the aft side at the top of the taper where it's it narrows down, and that gives me the center line for the rudder post. Then I've just crossed those over, and that is the point, the center point at which this arm needs to turn. Now it's slightly different because this arm's got a return spring on it, and we've actually got to line some arrows up, which I'll show you in a minute. But that's where that's going to go, and that clears, and then we have that hole there, the second hole we've got to use, this second hole here. And then what I also did was I measured from the center of the hole on the quadrant arm to one side of this, which was 235mm, and I wrote it down there, 235. And I now know how long this arm has got to be. It's got to be 235 long, less half the distance of that. So that gives me a measurement for my rod length, which I can then cut. So I'm going to drill the holes for this and get them lined up first for the arm. Get this all lined up first. And then I'm going to take the quadrant arm off. Now, taking the quadrant arm off, so I may leave that until tomorrow morning, but get all the other bits done, because I've actually got to take the quadrant arm off, drill and tap two small M5 holes in, and bolt that down, unless I can find an adapter which will turn this 6mm thread into an 8mm thread, and I don't think I've got any. But we shall see. Okay, so this is now mounted on here, 3 pilot holes, 3.2mm, some stainless screws into there, and no, that's not the wrong way round. As I said earlier, how well you can see this, but there are 2 arrows that have to line up when that's in line with the quadrant arm. So at the moment it's halfway through its travel, but it is sprung to go back to that position, which is 70 degrees, so it moves 70 degrees in each direction. So when that's there, it just keeps the tension on those 2 little ball joints. So this will now go into that second hole there, get cut to length, and what I'm going to do is I'm going to take the quadrant off in the morning, and I think what we'll do is we'll paint the base with some epoxy paint, get it in maybe, and then it will screw back into position. I'll give it a little bit of a sand and a clean up first. So last night we gave the timber a coat of epoxy and painted it this morning with some white acrylic just to protect it in there. It doesn't really need protection, it's a dry area, but it should be okay. I've mounted the arm in the correct position, and those 2 little arrows line up when it's at the right angle. I can't get the tiller arm off. It's 4 8mm bolts. That's 4 8mm bolts, and I've got a pretty long Allen key, hex wrench, and I can't move it. They're the bolts appear to be set into some kind of Loctite, and then they've been QA marked with a hard paint, and I can't even move them. And that's, you know, a foot long, 300mm long, and I need a rattle gun to get them out, or maybe a little bit of heat. Now we can't do that. So the solution, I think, is to do away with the piece of plastic which this stands on, which would have had 2 holes in it. And what I've got is some stainless steel, I don't know what you call these, but there is M6 thread inside with an Allen head on the other side. I've got a couple of those. Now if I drop that through the hole in the tiller arm, in the quadrant arm, I can then put a washer on the end of that. Yeah, I can then put a washer on the end of that. This will go up through the tiller arm, and I can tighten that because it's got 2 flats on it against that. A little bit of Loctite in there, and that won't go anywhere. There we are, that is now fitted on there, so that did work. And we have a stainless washer on there, that goes through, and all we have to do now is to put the threaded rod into there and the lock nut at the right length when that's in the center position. So we're almost there, just on the home straight, and then we can connect it up. There we go. That'll be in that position, 2 arrows lined up on the back, and then as that moves, as that quadrant arm moves backwards and forwards, this will send the signal to the computer. Okay, let's measure that bar and put it in. And there it is in position. So that's, I marked that with a Sharpie pen. I marked the inner and outer mark, put the rod, screwed the rod right into one the other side, so that I knew I'd got enough. If I cut it short, I put that back piece, you see it there, the back arrows in the right position, marked it off, and then screwed that ball joint into the second hole, which is the one that they recommend. And I've routed the cable round there, put some tie wraps around it, tidied it up, and I'll cut those ends off in a minute. And I've moved it from full port through to full starboard, and no issues, nothing catches, etc, etc. And then at this end there, that orange plug, that is into the data computer. That was fairly easy. Hopefully now this is plug and play. We'll go and try it on the old electronics. Now all we have to do is set up the head-in sensor. So into standby with your heading on. Press menu. Then press setup. So that's down 1. Select that, then come down to system, and then system, select system units, north reference, power units, low voltage, language, operating mode, system information, and then you press and hold the center key for 5 seconds, and then you press the back button twice. Back. Dealer autopilot setup. There we go. Select that, and we want the Wizards vessel type, sailboat, yes.
wizards, select, and then we go dockside wizard and begin. It's a sailboat. Move the rudder to a position that will turn the vessel fully to starboard, so that will be there. Turn the wheel and then press OK. Move the rudder to a position that will turn the vessel fully to port and then hit OK. So wheels going over, fully to port, OK. Centre the rudder using the indicator below and select begin. The autopilot will briefly take control of the rudder. Well, we're at anchor, so it won't be going anywhere, and our top mark for our wheel is there, so that's it. And then using the indicator below, right, there we are. Calibration complete. Okay. Now we have to do a sea trial and calibrate that, and we'll do that. That's done. And then the next one will be a sea trial wizard, and we can't do that at the moment because we need an absolutely flat, calm sea. But yes, we will do that. So there we are. Back, and we're in the centre, and we're on the centre mark of the wheel, so that looks about right. I've made this 3D drawing of the bracket, which we're going to have made up when we get to our winter mooring. If this is going to be useful to you, then I'll find a way of getting it to you if you ask for it in the description. You may have to define the angle of the back of the bracket, as it can vary from boat to boat. There's some useful links in the description, but I hope this video has been really helpful, especially for those of you who have got a Jeffa steering arm and Garmin electronic autopilot. This problem is known about, and it does reoccur even if you replace the pot inside the steering sensor. So if yours is starting to act up now and then, it might be a good idea to think about changing it before your autopilot goes on a long sea voyage. Sail safe.